So welcome to another brand new video on my YouTube channel, Talk Codes. So this is the second video of my physics engine series, and in the previous video we've covered all the theory behind that how a physics engine is gonna work. Now in today's video we're gonna go through a bit of coding, nothing too fancy. Everything is pretty much basic, just to implement those formulas in a real world application to simulate how a bouncing ball is gonna move in real world when it is a drop from a specific height with a specific velocity, and pretty much that's all. But before we go through the video, if you haven't subscribed to my channel yet, please hit the beautiful red button down there, subscribe to my channel, and if you are interested in supporting me, you can just simply share this video with anyone who you think that may be interested in these kind of content. Alright, so let's go and see what is the final product, what we're gonna make, and after that let's go to the coding. So let's move. Do it once again. Yeah, so as you can see, it is working like this. It is being dropped from a specific height, and just like a real world ball is gonna go and bounce on the ground, and that's because of the gravity force of the Earth, or at least a very basic simulation of this. Now let's move to the IDE that we're gonna use, or code editor, or whatever. All right, so I'm gonna start a basic terminal. All right, so let's start. So we're gonna open a terminal in order to create a directory. You can use the GUI as well, but I'm going to use the command line. So I'm going to go to our desktop, and then here I'm going to create another directory using mkdir or make it directory or something. And then we're going to call it yt underscore video, yt phys. Let's do it. Yt phys, right? And then we're going to do a cd, change directory to yt phys. And then here, since we're going to open Visual Studio Code, we can simply write code and put a dot, so it will open a new project in this specific directory in Visual Studio Code. So let's hit it. Now, yeah. Okay, so we got this here, code in any language. All right, so this is... Let's start with a new file. We're going to call it index.html, since this is very basic HTML thing. Start the HTML sample. So good. So let's clear some of these extra lines. So this is our title. This is just very basic HTML. We're gonna put our canvas here. So we're gonna call this, let's say, bouncing ball. The title, right? Bouncing ball is our title. Alright, so since we're gonna put our canvas in our body, here in the body we're gonna put a div, just to make things, to put things clear together. And then inside of this div we're gonna put a canvas, and then in the canvas, our canvas is gonna have a width of, let's say, 600 and height of also like 800, let's say. Right? I guess that's all. And since we're gonna create a reference to this canvas, because we're gonna put a little bit of style, we're gonna put an ID for this. So let's say this is our game screen, right? Game screen. Now, in order to style this, we're gonna make a style tag here, and let's say, all right, so we are here we're going to put a reference to our canvas. So we're going to simply put the, how do I say, the ID here, game screen, and we're going to design. And so display is going to be block, since everything is a bit of block here. I mean, if you're going to have a canvas in your screen and you're going to have a lot of other items in your page, in your whole page, then it's going to be a block of that page. So this is why we're going to use display a block, right? I'm going to put a margin of, let's say, 10 pix, so I guess that's 10 pixel. So, and what else? And we're gonna put a border here. It's gonna be like 1 pixel, and the color would be, let's say, solid black. Huh? I guess, yeah, so that's good. And right, so this is the HTML. I guess that's enough. And we're gonna create one more file for main.js that we're gonna call, so main.js. Here is our JavaScript. So first thing first, we're gonna use our canvas. Okay, so we have a canvas in our HTML, and we're gonna put a reference in our JS code to that canvas. So that basically, let's say we're gonna have a variable for that, and let's call this canvas. Okay, so it's gonna be document get element by ID. So this is a very common thing in JavaScript. When you want to put a reference in your JavaScript code from an element in the HTML, you're going to simply put this. So document is going to go for the whole source of our page, and then get that specific element by our ID that we're going to giving to this line of code. So our ID, since our ID is here game screen, then that's enough. We're going to put game screen here. So this is our reference. And one more thing is that since our game is a 2D game, we do not require any kind of those libraries from 3D rendering and other stuff. And we're going to say this to our browser using var cdx. This stands for context is equal to canvas dot get context. Let's say context. And then it is 2D, right? So it is better to put at least a little bit of comment in your code. So we're gonna put 2 slash together as a comment, and we're gonna call this, let's say, link to HTML, right? Just to make things clear. All right, now we're done with the first part, which is linking our JS to our HTML. Now let's start creating our world. I mean that basic square. So we're gonna put another comment. Our world is gonna have a width, a height. So let's say variable of width, very basic 600 here, and then let's say variable of height. It's gonna be 800. Simply, our world is gonna have a gravity. Since we're gonna simulate the real world, we're gonna put variable of gravity equals to 9.8, since we're going to try to simulate the real world. So gravity in Earth is 9.8, and that's it. So then we're going to have the FPS, frame per second. You can search about it. I'm not going to get into that, but I mean, let's say we're going to have variable E, and that's 0.8, all right? So what this means, so this E is going to, every time that our ball hits the ground, it's going to lose 0.2 of its energy, let's say, right? So it's physics, basically. So we are done with a world, okay? We need a ball, since we're going to create a bouncing ball. And we're going to use a function here. So we're going to define a function for our ball. I'm going to say we're going to have a ball. It's going to have an x. Let's say since we're in the 2D world, so that means we're gonna have an x and y axis. So we're gonna put x, y, and then obviously it's gonna have a velocity. So we're gonna put a velocity, that's the speed. And then we got obviously a radius. Since it is a ball, it is a circle. So we're gonna put a circle, and the circle obviously needs a radius, okay? And it has a mass, since it is an object in the real world, because we're gonna simulate the real world physics. So it requires a mass. And then what else? Let's say we can also define a color. Yeah. So all right. So this is our ball. This dot x is equals to x. This dot y is equals to y. We got also this dot velocity is equals to velocity. I mean, this line simply means that the x that we put here is actually the x for the ball. So then we got this dot radius, which is the same radius that we put in the brackets, and then this is mass is also the same mass that we got in the bracket, and then this dot color it is the same color as well. Okay, so we're done with this part. These are the spec of our ball. Okay, so in order to define the position of our ball in the space, we're gonna have an update function. So let's say this update is equals to function. It's gonna be like this. And then this is the function that's gonna calculate all the math, all the formulas, and we got one more function. I mean, because we need something to draw our ball on the screen, and that will be our function draw. So let's say this, the draw is equals to another function, and simply that's it. All right, so we got two functions, this the update and this the draw. So update is gonna do all the math, all the calculations. So it's gonna do all the calculations, and this is gonna render actually. So it's gonna render the world. Okay, so we got our function here. That's the update that is gonna do all the calculations for the, let's say, calculations and collision detection. Right? Collision detection. Right? So there's something that we need to define. See, a ball has a coordinate. I mean, imagine a 2D world. Just imagine a paper, and then on that paper, on that board, there is a ball, and it has two coordinates of x and y. And each of those coordinates are gonna, those coordinates together are gonna give us the location of that ball in our world, right? Since the only object that we have in our world is the ball, all we care now is the ball hit the ground and two walls on the right and left side of its world, right? Alright guys, so let's define the first collision, and that's obviously the floor or the ground. So let's define a constant value for, let's say, ground collision. So we are talking about a ball. The x coordinate of that ball is based on the dot in the center of the ball, right? Or x of that circle, we're talking about the dot in the center of the circle. So let's say this dot, let's say since we're talking about ground, all we care is the height, and now what variable that is defining our height is actually the y. So let's say this dot y, right? So let's say if the ball is gonna hit the ground, it also has a radius, okay? So as I told you, this y is actually the center. Now we should add the radius because we don't define it as the center of the circle is gonna hit the ground. Actually, the ball just touched the ground. So let's say this dot y plus this dot radius, and the y coordinate plus the radius is bigger than let's say the height, right? So we're talking about the height of the map. Height, then in that case, it would be a ground collision. Now let's define the collision on the right side. So let's say constant of right collision, right? So since we're talking about right and left, all the key actually x and y. So let's say the x, sorry, not y. So this dot x plus, let's say this dot radius is going to be bigger than the width of the map. So this width belongs to the map, the world. Now let's move on to the left collision and say constant of actually left collision. So it's going to be this dot x. And since we're going to go to the left, the value is going to be subtracted, not being added anything. Okay, so it's going to be this dot x minus, once again, this dot radius. And then here, since we're going to the end of our map in the left, then that value would be 0, okay? If we like subtract the radius of the ball from its position, then it's going to be a negative value. So in that case, that means that the ball is going out of the, let's say, out of the map. But one more thing is that, let's say, constant of x collision. So any collision in the x in the x direction is going to go on a logic like this. All right, so when we want to define the collision, all the collision, no matter left or right, all the x collision is going to be, let's say, right collision, and we're going to do two pipelines together. So that means in programming, this means like or. Okay, so that means if we write something like right collision, this sign, and let's say left collision, so that means it can be either this or this, right? Oh, I mean, it's impossible to hit the both sides at the same time since we're going to have one ball, but this is the logic that we're going to use in order to handle whether it is left or right. Okay, let's say, let's comment this out. So it's going to be our collision detection logic. Okay, after that we're going to go with some if and else, since we're going to write a basic logic for our calculations. So it's going to be if, all right, so we're going to start with if we hit the ground, if ground collision, and simply if we hit the ground, that means that the direction, or let's say velocity, okay, so in physics, velocity has direction with it, okay? So if we hit the ground, the velocity, the sign of the velocity should go in reverse, and if it is positive, then it's going to be negative, or vice versa, okay? So it really depends on the direction. So let's say this dot, so our ball has a velocity, this dot velocity is equal to this, to let's say minus this dot velocity. So we're going to write it in reverse. Every time it hits the ground, it's going to lose some of its energy, and we've defined E on the top. So let's say this dot velocity, so it's going to lose some of its velocity. It's going to be like this. All right. Once again, this actually is the same as if we write something like this. The velocity is equals this, the velocity times E. Okay, so these are the same, but we're doing this for the sake of ease. Okay, so that's pretty much the same. All right. So now we got this part. So this is the case that it reaches the ground, it hits the ground, and this is the collision that it's gonna happen. If it doesn't hit the ground, then it will be, let's say, the velocity is going to be under influence of the gravity force, okay? So gravity force is a force that is being applied every time in our world. So the time in our world, this time system in our world is the FPS. So since we're simulating the whole world, so our time in our world will be based on our FPS. So it's going to be based on gravity force times the time of our actually world, so it's going to be FPS. So this is the time, okay? And this is the logic for increasing the velocity based on time, and of course the force of ground. Okay, so this is the logic for ground collision. Now let's move to the logic for side collisions. So let's say if it hits either of the sides, let's say if it hits like X collision happens, it can be left side, it can be right side, no matter what, it's going to be X collision. So guess we're missing something. Let's check. So yes, there's one thing that we're missing, and that's the velocity of actually y. This is the velocity for y. We have two velocity, one for going to the right and left, and the x axis, and one for actually going up and down. So that's for y. And we're doing both with just this one variable for velocity, and that's wrong. Okay, so instead of that, we're gonna do a very little refactor in our code. So let's say we got velocity in y axis, and it's equals to the velocity, and let's say this dot velocity of x direction will be also equals to velocity. Okay, so now I guess it's fine. Now we just need to change our code, since for the ground we're gonna have velocity in y direction, this dot y. Alright, so let's say what else we got. So this is velocity in y direction is going to be this, velocity also in y direction, so that's fine. Alright, so now we got this. Now let's go to the x collision. Alright, so just at the time that we hit the wall, then our x collision would be in reverse. So simply we're going to write this, that be x, which is our velocity, and x direction is going to be exactly the same, this dot velocity of x times a negative 1. Now, based on the velocity, we're going to change the direction, change the position of our ball. So position is based on x and y, which is in our, which are our coordinates. All right, so the y is going to be increased using, based on the y velocity times the FPS, which is our time. And we're going to write a times 100 because since this FPS is based on the frame per second of our machine, so it really depends on your machine, but in normal computers, I guess this 1/40 is fine. And we're going to add this times 100 so that we want to, like, we're going to simulate the way that it's going to be like in real world, okay? Okay, so for the x direction, we're going to write this to x, and simply we're going to increase it with the value of x velocity. Okay, so this is the x and y, the way that our ball is going to move. So now that we have all the calculations, all the conditions and everything, simply we're going to go for here, this dot draw. So we're going to update everything using our draw function based on these information, right? Okay, so we fixed the existing error because it was one of these curly braces was missing. So now everything looks fine. Okay, so enough for today's session. I guess this video is enough for now. In the next video, I'm gonna go to actually complete this code using a draw function, and we're gonna do a little bit more. And once again, guys, if you haven't subscribed to my channel yet, I really appreciate it if you go hit the beautiful red button down there. And if there's any question or something, you can ask in the comment section. I'll answer them ASAP. All right, stay safe. See you soon.